So
So
what we're about to do right now is 4.3.
yeah, so we're doing 4.3 in the book right now, and 4.5. I'm going to intertwine it with this 4.3, which is, so we're looking at quadratic equations, which is 4.3, and then 4.5 will be quadratic inequalities. And so recall quadratic equations were written in the form. We're written in the form y is equal to ax squared plus bx plus c. In order for this to be quadratic, a cannot be 0. If it was 0, then we'd have a linear equation. The value in front of our x squared tells us about what direction our parabola is facing. And so if the number in front of the x squared, that coefficient, if it's greater than 0, the parabola faces upwards. If a is less than 0, then the parabola faces downwards. So just looking at that coefficient in front of the x squared can tell you what direction the parabola is going. Notice where it's changing direction from decreasing to increasing here, or where it's changing direction from increasing to decreasing here. These are called your vertex. And so if a is bigger than 0, notice that the vertex is a minimum value. And if our parabola faces downwards, our vertex is a max. Sometimes quadratic equations are written in a different form. And I think it's called the Vertex Form, but let me just see what they call it. Vertex Form, yeah. So if you have a quadratic equation in vertex form, this would be y is equal to a, parentheses, x minus h, quantity squared plus k. And when it's in this form, we can actually tell what the vertex is. It's at h, comma, k. Which makes sense if we think about this. If we had y is equal to x squared, and then notice here we're just plugging in x plus h, or x minus h. So remember that minus h, it's shifted to the right, opposite than what we thought. H units. So normally at y equals x squared, right, our vertex was at the origin, 0, 0. And so this minus h, that's going to shift it over h units. And then the k value, this plus k outside, this is shifting it up or down. And the number out front, that a, it depends, remember what our sign is. If it's positive, it's going to be facing upwards. If it's negative, that reflects it across the x-axis. And then also it does the stretching and the shrinking. reflection, and stretch or shrinks. I think they call it compressed in this book, stretch or compressed. So basically this vertex form is just using transformations of graphs on x squared. And so you can think of it that way, or I just kind of know my formula. My vertex is at HK here. From that, so if f of x is equal to negative, and then x plus 4 quantity squared minus 1. So let's find the vertex. I'm going to find the x and the y-intercept if they exist. Let's just first do that. So the vertex is already in that vertex form. So opposite sign in here affects our x value. So it's going to be -4, comma, and the y value, it's the same sign. So it's going to be -1. Okay, so we have a vertex at -4, -1. So before I even go to figure out if I have or find my x-intercepts, we can know by where our vertex is and what way our parabola is facing if it will even have an x-intercept. So if we go over here, we went over -4 and down 1, we have a point here, right? And then the value in front, this minus sign, this is my a value. So a is equal to -1 here. This is less than 0, so my parabola faces downwards. So noticing my vertex is below the x-axis and it's facing downwards, notice that this cannot cross the x-axis. But let's just say that we forgot. We didn't know about that. Sorry, I was just worried I didn't start the recording, but I did. So let's say we just didn't realize that and we went through to figure out what the x-intercept is. So we know to find the x-intercept, we set y equal to 0. So we have 0 is equal to this negative all times x plus 4 quantity squared minus 1. And if we solve for x here, I could either expand this out and then distribute my negative and then try to factor, or it looks like I can use my square root property. Let's isolate this quantity squared. So if we added 1 to both sides, we get 1 equals negative x plus 4 quantity squared. Get rid of the negative in front of the quantity squared. So we get -1 is equal to x plus 4 quantity squared. Use the square root method by taking the square root of both sides. And this is where we come up with a problem. So -1, the square root of that is an imaginary number. It's not real. So if we get something back that's not a real number, it's not going to cross. Again, so that's what would happen if you hadn't looked at your graph and looked at it and did the reasoning by that. Find your y-intercept. So find the y-intercept, that's when we let our x value equals 0 and we solve for y. So that would give us negative, I see an x, I'm going to replace it with 0 plus 4 quantity squared minus 1. Order of operations, we have negative, square the 4 first, we get 16. So negative 16 minus 1, which is negative 17. So we have a y-intercept when x is 0, y is negative 17. And then put it all together, we can graph it. So we have the vertex was negative 4, negative 1. Let's go way up here. And we have the y-intercept is at negative 17. Oops. Okay, because this is a parabola, parabolas are actually symmetrical. If we drew a vertical line through this vertex, this would be a mirror image across this line. And this is called the axis of symmetry. So we know this point here was 0, negative 17. That distance here, right, was 4. So if we go out another distance of 4 from the axis of symmetry, the other direction, our y value should be here at negative 8, negative 17. So there's a point symmetrical that we already know. And so our graph looks like this. So the axis of symmetry is always going to be this line, x equals h. In our case, it's x equals negative 4. Right, because this is always going to be the point right here, hk. And so the vertical line through that x value would be h. The domain, well, domain for quadratics are all real numbers. The range, though, so the range, well, always look where your vertex is. It's either going to be smaller and equal to what that vertex is, or it's going to be greater than or equal to. So in this case, where our vertex is at y value of negative 1, that's the biggest y value that we have. So we're coming from negative infinity, hitting all the y values from negative infinity all the way up until we get to negative 1 included. You should be able to tell where the graph is increasing, decreasing. So increasing, it's all the x values you're using. So notice we're going up until we hit the x value of negative 4. So it's increasing all these x values here until we get to negative 4. So negative infinity to negative 4. It's decreasing and it's going downhill left to right. It's starting at negative 4. And then it's going on forever. All the x values this way. So this would be from -4 to infinity. We have an absolute max. So the absolute max, remember when we say the maximum value, it's the y value. So we have an absolute max of -1 at x equals -4. Okay, so that one section, the 4.5, just takes this a step further, and it says, okay, let's look at our graphs, and let's see when is it bigger than or equal to 0, or when is it smaller than 0. So if it said find where f of x is greater than 0. So this is saying when is the graph falling above the x-axis? This is when my y values are positive. So what x values give you positive y values? If you look at the graph, when is this graph above the x-axis in this case? And this graph, notice, is always below the x-axis. So there's no y value in this case where this graph is bigger than or equal to 0. So for this function, it's never. Where if they had asked us, where is this? When is f of x less than 0? So when are the y values of this function? Negative. Well, our y values are always negative. And so in our case, this would be from -infinity to infinity. So really the important points when we're trying to figure out if a function, a quadratic, is greater than or less than 0, the important points that we really need to look at is where are x-intercepts. And where those x-intercepts are, the graph is either going to be falling above it or it's going to be falling below it, where it's crossing or touching maybe. If it's touching, then it usually just turns around, and we'll talk more about those types of functions later. So let's say you did not have it in the form where it was that vertex form. So let's say you had -3x squared plus 3x minus 2. So a couple of things that we can do, and let's just do it just for practice. We want to put this in vertex form. Well, in vertex form, remember that it looked like it had a perfect square. This was y is equal to a all times x minus h quantity squared plus k. So we've learned how to make things perfect squares before. So let's complete the square. So we need to complete the square on this. And remember, when we completed the square, we couldn't have a number other than +1 in front of our x squared. So instead of dividing everything through by -3, let's pull out -3 from just the x terms. So we're going to factor a out of just the x terms. So if I pull out -3 from just all the x terms, that would give me +x squared minus, this would give me 1x. Instead, we're going to add something here to make it a perfect square.
You still gotta go to work?
And then we're going to subtract it. So we're going to add that special 0. So minus. Last time we used to add it on both sides of the equation. Here, we're going to add 0. And then we have this plus k. Or minus, sorry, we have this minus 2 out here. Okay, so we have -3. We need to figure out what we need to add to make this a perfect square. So remember, we halved this number because that would be the same number you would add to get itself. So half of -1 is -1/2, and then we squared it because it was the same number you would multiply and got here. So -1/2 times -1/2, this is 1/4. So I want to subtract 1/4.
How did we get 1/4 again?
To complete the square, it's always the same number that adds to give us this value has to multiply to give us this value. And so the trick is to look at the coefficient in front of the x terms here. Once that a is 1, divide that number by 2 and square it. And so our b value was -1 here over 2, square it. -1/2 times -1/2 is +1/4. The whole point of that was so we could rewrite this as a perfect square. I do not want that -1/2, or no, sorry, I don't want this -1/4 inside the parentheses. So I want to move it outside of the parentheses, and in order to move it outside of the parentheses, it has to be multiplied by this coefficient outside because it's multiplication. So moving this outside of the parentheses, I'd have -3 times -1/4 is +3/4. And then I have this -2 still outside. So I got -3. This is now a perfect square. That is x minus 1/2 quantity squared. Get a common denominator to add these numbers. So our common denominator is 4. So let's multiply -2 by 4/4. So this is 3/4 minus 8/4. 3/4 minus 8/4 is -5/4. This is f of x. And it asked us to put this in vertex form, which we just did. And we can tell what the vertex is. Opposite sign, because that's what's moving it left or right. So 1/2. Outside was the same sign, -5/4. Okay, so let's look at the graph. If we looked at this and we plotted 1/2 -5/4, so 1/2 -5/4, that's down here, right? It's -1 and 1/4. So that's here. I just happened to pick another one that doesn't cross. And this is our a value is negative, so it goes downwards. So there's not going to be an x-intercept. And then the y-intercept, if you go back to your original function, that's the easier one if it's not in vertex form. And we look at f of 0. Well, all of our terms with an x go away because x is 0. This is equal to -2. So we have a point, our y-intercept, so I just happened to go through that point too, is at 0, -2. The axis of symmetry, the line that it's symmetrical across, is x equals 1/2. Okay, there's a vertex formula. So you can find the vertex without going through the work and completing the square if our function is not in this vertex form. And so if you wanted to find the vertex and not put it in this vertex form, your x value is -b all over 2a. Your book gives you how to find y a different way, but I tend to, well, if you know the x value of your point, right, all you're doing is plugging that in wherever you see an x to get what y is. So if you had f of x equals 4x squared minus 8x plus 3, and it says find the vertex. Well, if I look at -b, so I have this is equal to negative of -8 all over 2 times a, and my a value here is 4. And simplify, so you have negative, so that's +8 all over 2 times 4, which is 8. 8 over 8 is 1. So x equals 1. But that's just the x value of our point. And so let's plug it back in wherever we see an x and f of x. So if we look at f of 1, that's 4 all times 1 squared minus 8 all times 1 plus 3. So 4 times 1 squared is 4 minus 8 plus 3. So -4 plus 3 is -1. So our vertex is at the point 1, -1. Knowing that, I could actually even put this in vertex form. We now know what h is. We now know what k is. And we can look at our original function and know what a is. This a value is 4 all times x minus h. Well, my h value here is 1. So -1 quantity squared plus k. And our k value appears -1. So plus a -1, or I can just put -1. Okay, so we just skirted around having to complete the square by using the vertex formula to find that point, and then plug in stuff. One other thing really quickly is the discriminant. I feel like we talked about this already, but maybe we didn't. So remember the discriminant? This was the b squared minus 4ac. That was the value when you were using the quadratic formula underneath the radical. The discriminant tells you what type of solution you get back, if it's going to be real, if it's going to be imaginary, and how many solutions. So the discriminant b squared minus 4ac, if this is greater than 0, we have plus or minus a real number. So you have 2 real solutions. So it doesn't tell me what the solutions are, it just tells me there are 2 real solutions. If b squared minus 4ac is less than 0, well, that means I'm going to have a square root of a negative number, and a square root of a negative number is imaginary. So negative b plus an imaginary number, negative b minus an imaginary number. So we would actually have 2 complex numbers as solutions. And then the last case is that value underneath that radical, b squared minus 4ac, could equal 0. Well, square root of 0 is 0. So when I'm adding 0 to negative b or subtracting 0 from negative b, it's the same thing. And so there's only 1 real solution. So if they give you any application problems here or word problems, it's like going to ask you to minimize or maximize something. These are all quadratics that you're going to be dealing with. So minimum or the maximum value has to occur at the vertex. And so just if they throw a word problem at you, you know that it's probably going to just ask me to find the vertex to find what the max and the mins are. Okay, so I rushed through 4.3 really fast, but we got through it. I did not touch on as much as I wanted to on 4.5. So we'll look at that next week. So just a reminder, no class on Tuesday. That's a professional development day on September 29th.